Hello and welcome to ElectroPHY channel. In this video, we want to talk about Curie temperature or Curie point. The Curie temperature is the temperature above which certain materials lose their magnetic properties. It means that in the presence of a magnetic field, it won't be magnetized. For example, if you approach a magnet to a hot ion, it won't attract the ion. The reason will be explained in more detail. This temperature for ion is about 770 degrees centigrade. In this table, you can see that each kind of metal has a different Curie temperature. Actually, what happens when a metal temperature is reached to Curie point? On the atom scale, metals, like all materials, have magnetic dipoles. Most metals are ferromagnetic, which means that their magnetic dipoles are aligned in several domains. When they are in the presence of a magnetic field, these dipoles are aligned in one direction, and that's why the metal is attracted to a magnet. But what happens to metal when its temperature reaches Curie point? In Curie point, magnetic dipoles are no longer directional and they rotate in random directions. Even in the presence of a magnetic field, they are not aligned, so the metal won't attract the magnet. To visualize this phenomenon, we want to show you an experiment. In this experiment, we pass lots of current through an iron rod. The rod temperature rises because of Ohm losses. Then we try to stick the magnet to the rod, but it won't happen, and the magnet tries to stick to the cold part of the rod on the corners. Now we wait for the rod to get colder. As you can see, the magnet is attracted to the rod because its temperature is now below Curie point. Let's do this experiment in a different way. We have attached the magnet in the middle of the rod where temperature rises first. Pay attention to the movement of the magnet. You saw that the magnet tried to escape from the heat. And that's due to the loss of magnetic property in the middle of the rod because of Curie temperature. Let's a little talk about our test setup. The setup consists of an autotransformer and a transformer. The secondary of autotransformer is connected to primary of transformer, and the rod is connected to the secondary of the transformer. The transformer secondary voltage is 10 times smaller than the primary, and the secondary current is 10 times bigger than the primary. So the current passing through the rod is that much big to increase its temperature. Another thing we want to show you in this video is resistive or Ohm loss. The simple concept that we have used to increase the temperature of the rod. The loss formula has a direct relation with resistance and squared current. This loss is in the form of heat and light. After a few seconds, the loss increases and the iron rod melts, so be aware of choosing proper wire in your design. Special thanks to Professor Mohseni, Head of Electrical Machines and Electromagnetics Elementary Lab of Tehran University. Thanks for watching, hope you learned good things. If you like this video, hit the like button and subscribe to support our channel.